Homework 5, exercise 6. I like this one, so I want to spend some time on it because I think this has some really nice mathematical principles in there. We're going to suppose that x and y are chosen uniformly at random from the set 1, 2, up to 100. And we're going to have z be the minimum of x and y. We're going to think about what we think the expected value of z should be. So definitely should be less than half. But I don't know. Maybe I'm going to guess, less than half of 100. Maybe I'll guess it's 33 or something. I'm really not sure. Okay, so let's see if we can work it out. So let's forget about up to 100. That's a lot. Let's go up to 4, which is still going to be a lot, but hopefully will give us some sense of the structure. So what are the possible things that we could have for x and y? Is we could have x is 1 and y is 1, x is 1, y is 2, x is 1, y is 3, x is 1, y is 4. Or we could have x is 2, y is 1. Okay, x could be 1, x could be 3, y could be 1, 3 and 2, 3 and 3, 3 and 4, and then lastly 4 and 1, 4 and 2, 4 and 3, and 4 and 4. Okay, here's what I want to point out. Of course, we could do this up to 100, but I think it's easier to think about for 4. Here's what I want to think about. In all of these cases, z is going to be equal to 1. And in all of these cases, z is going to be equal to 2. In all of these cases, z is going to be equal to 3. And then kind of only in this case is z going to be equal to 4. So now we just need to ask how many of them are there. Okay, so let's look. This yellow band has 4 plus 3 of them. It has 7. And this next band sort of has one less in this row and one less in this column, but we're double counting, so this thing's gonna be 5. And this is going to be 3, and this is going to be 1. Okay, so for this new problem that we're looking at, what's the expected value of z? Well, it's going to be 1, 7 out of the 16 times, plus 2, 5 out of the 16 times, plus 3, 3 out of the 16 times, and then lastly, plus 4, 1 out of the 16 times. Okay. So we can just add those up and we can figure out what the expected value of z is. I don't have a calculator here, so let's do this by hand. This is going to be 7 plus 10 plus 9 plus 1 over 16. Which we get some nice pairing. So this is going to be 27 over 16. Okay, this is obviously not for the problem we started off with, but this is for the case of 4. So what's it going to be then in the case of 100? So now going back and taking a peek at this. Well, here, if we do the 100 by 100 column, we'll sort of have 100 things in this row and 100 things in this column, but we're double counting the one in the corner. So we'll actually have our expected value of z. Maybe let's call this one z sub 4. This is going to be our expected value of the z that we care about, which is z100. And what's this going to be? It's going to be 1 times 100 plus 99 over 100 squared plus 2 times 99 plus 98 over 100 squared. Plus all of the way up until finally at the end, we're going to get 100 times 1 plus 0 over 100 squared. Okay. And now maybe there's some nice way that we can talk about this sum of numerators. So you can think about what that is, but of course we can definitely put this into a calculator. This thing should be pretty computationally feasible. Now you might be wondering, okay, well, what if that's a pretty analytic computation, but what if we're going to use R to compute this thing exactly? How could we do that? And there's some different techniques that you can do, but R can actually handle looking at all 100 by 100 things. So what you could do is you could look at all 10,000 combinations of X and Y. Since they're chosen uniformly at random, it's sort of equally likely to be any possible pair. So you could look at all 10,000 of them, take the minimum value, and literally just average over the 10,000. So you would go in order. You'd say, okay, this is 1 plus 1 plus 1 plus 1, and then 1 plus 2 plus 2 plus 2, and then 1 plus 2 plus 3 plus 3, and so on, all of the way 100 rows down in the case of 100, and you could have R computed exactly. But what's nice about this is, okay, this technique scales a little better, and again, you might think about this. Maybe there's some nice way that actually you could compute this thing by hand or make it a really simple calculation on a computer.